Okay, my friends, great day today. Extinct zoo put up 2 billion years ago, life accidentally created mountains. So I see this morning, I said, wow, this is fabulous. It only came out 30 minutes ago. So I looked at it and it's just not right. That's about the best I could do. When they talk about mountains, I'll show you what they have to say, little bits and pieces here and there. And this is a free use act, fair use, where I'm just commenting on their comments. All right, so let's get started. I'm going to first of all show you what mountains literally are made of. Okay, their claim is that plankton was all over the ocean. Now again, this is extinct zoo, and that the plankton was everywhere in the ocean, and then it all died off and fell to the below. Now listen to what they have to say. Here goes. I turn it up and we're going to put the words on, the whole 9 yards. Boy, we're getting ready. Here we go. Most of these planktons were bound in the ocean waters. These planktons, these little organisms. Here goes.
Oceans and seas, the only place they had to go after dying was downwards. And over millions of years, this mega generation of plankton slowly piled on top of one another on the
All right, slowly piled on top of one another. That's how they claim these layers were created, was plankton slowly piled top one layer on another.
seafloor, getting stuck in the mud and creating never before seen amounts of carbon. This carbon was then...
All right, just let's look back at that 1 second. Because Mudfossils is my area. This is not just layers of plankton and tons of carbon. Well, we are carbon-based life, and that, my friends, is layers of body tissue. You know, this is kind of funny. They're saying there was something lubricating these tectonic plates. They call these tectonic plates. That is connective tissue and muscle. And guess what? This is called synovial fluid. Yes, that's the fluid lubricating. And guess what? Synovial fluid is 4 times slipperier than Teflon on Teflon. It is the most fluid lubricant in the universe, is synovial fluids, and that is what is lubricating the tectonic plates. And I can agree with that. You get water in with the synovial fluid, it just turns into like a slime. Okay, my friends, I found that amazing that they were looking for these fluids that are slippery. All right, now listen to this. This is what they're going to claim is what caused, plankton caused everything, is what they're saying, basically. Here goes.
There was something lubricating tectonic plates, but it was only in the recent study that ancient plankton was indicated to be the suspect. And due to the sheer abundance of this slippery soft...
You see this? It's not going to be like this. These are layers of membranes and tissue. As I will show you, it's not even possible to deny it, as I will show you.
Graphite, the mountains they formed were nothing like those of today.
All right, let's just go to the source of the problem here. All right, let me just quickly show you this. You see this? This is the west coast of the United States, up by Oregon. Let me show you what is on the coast of Oregon. And these are mountains. Some kind of elevation they claim was caused by accumulating plankton. All right, they're talking about plankton creating mountains. Well, I'm talking about biology. This is a bilipid membrane. All the things I was showing you with those layers that they talk about is because of these membranes. Now look at this. This is this layer here is phosphorus, and they band together. These are really glued together, all those balls. And then there's a layer of fluids, and then there's another layer exactly like this. Well, guess what it is? This is where Tyson is, out on the west coast. This is the lower layer. That's the upper layer. They sit in these holes, which are called protein channels. Normally proteins flow through there. You see the little edges around here? I know you can see that. You see those edges around there? That's the glue. That's literally the glue that glued all this stuff together. There was no penetration through there unless you were sick. That's what sickness is penetration through membranes. It's invasion. These gluey substances are supposed to be tight junctions. Sometimes they get loose, and that glue is a specific chemistry. I studied all this stuff, from the biology, the chemistry, the physics, and this was from a gigantic creature. That's no question whatsoever, 100% certainty. This is a bilipid membrane, and the size of this, I think it was over 6 feet from the top to the bottom. This is Tyson's Mudfossil venture. Very good friend of mine, Tyson Carlson, and that's what it is. That's what it is. There's no difference. Now, let me show you something what happened in Turkey. Remember what happened in Turkey, where that terrible earthquake came down? And it wasn't an earthquake; it was a collapse. You see the people standing over here? You see these little blocks and layers? Same stuff. Oh yeah. There's layers. Oh, there's plankton. No, it's not. This is blood. That's red blood servicing this sarcomere tissue. This was the Earth apparently is a gigantic corpse as far as I can determine, or very close to it, because these are nothing more than these right here. You see, remember this? Look at this. This is stone, and it's the sarcomeres. All right, and it's cut straight across here. So that's basically the upper skin. They got a little bit of bits of blood in it. Then you get into the muscle, the stuff that's you got a lot of blood running through there, which services these sarcomeres. These are sarcomeres. Now, what happened in Turkey, that blood ran out, and it left cavities in here, because that stuff is very, very fluid, and then everything just collapsed. And it's very, very simple to see if you just open your eyes and look. There's the blood. Now, way down at the bottom down here, I could find places where the blood just ran out. But you can see these are blocks of muscle tissue. This is not just something that happened for no reason. And that's blood right there. Now, there was layers of very dense blood in this lamination. I have other shots to show, but you can see the blood has to service the muscles, and these were muscle sarcomeres. There's some more blood up here. That right there is a little blood vessel coming in, and that's what, as the blood ran out underneath, and they show up in sheets. As a matter of fact, I have one here. Hold on. You see, this is a pretty good example. This, as you can see, the pink, I hope you can see that, the contrast there. You see, the one in the front there is sort of pinkish looking. And that other stuff here, the same sort of looking tissue, only it's brown, there's no pink in it. That's because this is tendon. Tendon runs from the bone to the muscle, and then the muscle picks up, and then you need a ton of blood, That's why you have a whole big layer. Now, in Turkey, I believe this thing was upside down. This layer was on the bottom, and it just ran out, just like this layer ran out. All you can see here is that's the artery. You see that? That's the artery right there, that round little tube, and so are these. And they are letting their blood run down to service this muscle. And there's layers of muscle in here, just almost identical to what I just showed you, that they showed, saying this is layers of plankton. All right, just so you understand, this is the same bone, and this one shows the bone. The bone is not shown here, but it is right here. Now, something I want you to see. See this little dot right there? You see that? That's this here. That's the center of the tendon. The tendon runs over to the muscle. The muscle has to be able to go this way and that way, and then pull in and out like this. But it's got to be able to pivot. This is the pivot point. That's the pivot point. And basically all tendons, if they're like on your shoulder or something like this, and you have to move up and down, and they have to rock back and forth, this has to be flexible. And that's why you have all that fluid in there. the synovial fluids, they call them slurpees, small leucine-rich proteins, and they slide. This has to be able to slide back and forth. I'll show you in a second, because I have another big shot of something bigger than this. Now, so what am I showing here is no bone, because it's here. But then we go to the tendon, runs out, all brown. Then you get into, maybe this leg here. You can see a little better color. But anyway, this is where the muscle comes. And then all of a sudden, it transitions from very fibrous to muscle. And then it just falls apart. And there, you see that right there? This right there, that's abrupt transition. They come out with some pretty strong fibers because they got to be held tight. And then they turn into the muscle, where the muscle gives that really pinchy stuff. And here's what the muscle looks like in its sarcomere value here. Right there, that's what a sarcomere is. Now, what does it consist of? These little tiny stripes are connective tissue. And in between the stripes are the red sarcomere goo. I don't know how it exactly works, to be 100% honest with you, but they do contract, and they pull from this, which is relaxed, to this. This has got a little bit of a slip to it here. Normally they're going to be straight up and down when they're not damaged, and then when you tighten up your muscles, they pull together just like this. That's a sarcomere. And as you saw before, these are sarcomeres, identical to that, and these are flush with blood. These are sarcomeres too, in this olive grove in Turkey. I never heard a word from anybody about this. I said, you guys you're going to have more of this happening over there. Wherever there's going to be, if they can find places where there's red mud running out from underneath some of these mountains and these hills, that's where their blood is running out. If that's the case, it's going to be weak. There's going to be cavities under there, and it's going to eventually collapse. Like, these blocks don't hold up well. When they don't have any support, they just fall in, as you can see. And this was just an absolutely stunning collapse. So don't forget, this is the size of the creatures we're dealing with. This is a membrane. You should be able to hold that up and look through it and almost not even know it's there. That's how thin they are in us, these membranes. It's almost not even there. This is over 6 feet thick, from the top membrane to the bottom membrane. That's all it is, here to here. And I showed you these are supposed to be glued together. And I get into sickness and bodily invasion and everything. I learned a lot. I learned about the fascia. I learned about the fluid-filled highway long ago. 2015, I wrote all the papers about this stuff. And because I could see it. I could see them in the mud fossils. And I had my mud fossils DNA tested, CAT scan, and all that stuff. There's no question as what they are. And here they are on Earth. They're everywhere. This is nothing more than body tissue, too. And that's the red, bloody runoff. All right, there's the guy's van right there. And this is just some more blood sort of running out. And there's still some very, very wet red blood around the Earth everywhere. Blood is the preservative. And here's what, look at this. This is Huntington Beach in the United Kingdom. You see that? This whole thing's collapsing. That's skin. And that's body tissue. And these balls are the interstitium balls. And this is what they look like in body tissue. This is the mucosa, skin, fascia. It's the coating, the membrane. And remember we showed here, like in the other side, it could be skin, it could be a membrane, but it's going to have this, and then it's going to have a bunch of fluid stuff, and then it's going to have another layer. All of that stuff is held by these little balls, and they're tough, tough, tough. And all these little straps stay with the balls. All the rest of the stuff just runs off. But this is going to flush away as it gets washed away. And here it is laying there after it's washed away on the beach. And this is nothing more than mud, which is nothing more than eroded flesh. These are being invaded by sea creatures, basically some kind of sea moss that's eating into it. This is the red bloody flesh that's just eroded away, and the balls are tough. These are the Moki marbles. Same things as these. And here's what they look like in the creatures deep inside. These are layers of tissue that I show you all this stuff. It's just undeniable. It's here and it needs to be examined. We're just playing games. Remember I told you about the tendon? Right here, look. Right there, there's the tendon. That has to go like this. And when it does, these have to slide amongst themselves because it's twisting. This is the pin right there. All right? And that is the center, and they come out in a curve like this a little bit. Now, that's, where is it? Here's right here. Look at this. This is tendon. That's why it didn't erode. That's the only piece left. Tendon is tough, and tougher. There was a bone right here. There's the pin. Remember the pin? Here's the heavy-duty strap. This one doesn't have to slide among itself too much, a little bit. These have to slide among themselves a lot. But you still need a lot of strength here. So they have tons of layers. That's not the layer of plankton. These are all tendons. Now, right here, it started into the muscle. You see it starts into the red muscle here. And there was, this looks like where the blood was, sort of towards the bottom on this one. Now, on the top, that could, all this could be just from birds landing up there pooping all over, or it is actually the fascia, which is it loves, green things love to grow on fascia. They love it. And those balls that I showed you here in Huntington Beach, wherever that was, these are in salt water. Freshwater balls grow totally green, but they really get vibrant green. But they have to be in fresh water. This is salt water, different type of invasion. But still looking for the biological matter that is here. The biological matter, blood, feathers, bone meal, blood meal, makes plants grow fabulously. Feathers do too. These are the same kind of balls that were in flesh. This was flesh up here. And as all the flesh is eroded away, it's cheap. That stuff washes away. And wherever it was now, it appears that at some point this was pretty well frozen in for many, many, many years. And now it's, this is like global warming. 12 mysterious things scientists can't explain. Well, what the hell is going on here? Because look, way up here, look at how many there is in here. Look at these things, they're everywhere. But that's what skin is, it's everywhere on you. Now you see here these big red spots, these are going to be blood. It has to be fed with blood. There's going to be spots here that you could go and find where there was blood. And these are the balls that anchored the straps into the flesh. And that's why they're just laying around. Same as here, Moki Marbles, the same as the Huntington Beach. All of this stuff. And now I got much more to show you that it will just knock you away. This is only the start. And this is what this guy's washing off a piece of stone they're cutting. This is where the blood was running down through here. These are muscle fibers. The fibers of the things that we see on Earth are the things that are so enormous, as I just showed you. How are you you can't get your mind around it. That's the problem. They cannot get their mind around this. A 6-foot thick membrane. And this was all written about in the ancient past, about how big these creatures were. And I have so much more to show you, so much more detail. It's not deniable, it's only dismissible. All right, now, the next video is going to be all of this in extreme detail. It's going to shock the hell out of you, because every bit of this was written about. And what it concludes is something that you should want to look into. All right, I showed you the tendon that did this thing. This is the exact same thing as the one I showed you on mine, where this is where the muscle comes here. This is that pivotal point right here. So this whole thing can go this way and that way. And they have to slide back and forth. Now, they only slide basically outside, well, the tendons slide, but just a tiny little bit. The muscles slide a lot more. So don't forget, this is the pin. All right, so it's pinned here, and it goes this way and it goes that way. This is where the pin was. Now, somebody sent me these pictures, and I always get pictures, and then I try to contact the person. I ask them to do something, and usually I just never hear from them again. But I can show you this. This is so fabulous. I would love to see back here where it ends up, what it was attached to, because it had attached to something. But this is the attachment area right underneath here. Now, you see right there, that's the first abrupt transition. That's the second abrupt transition. And then you get into the muscles. Now, remember we talked about the slurpees, the small leucine-rich proteins. Up here, you don't have them. These are just anchors. The tendons are tough. And this is tendon. Now you get down to where the abrupt transition comes and you get into the muscle. You see, now you see the little, the gluey stuff. And really, that's what sort of holds it together. Now this goes from extremely fibrous to pretty fibrous, and then right into muscle, and at the muscle point it just falls apart. So you can see it's coming out here, and you still have to have some gluey stuff right in here, and then it turns into the muscle, and the muscle just eroded right out. But the gluey stuff appears to be like membraney, tight junction stuff. I'm trying to understand, because this doesn't have any of that, right? There's none of that. As soon as you hit this abrupt transition, boom, you run into this gooey stuff. But here in the tendon, you don't have that. There's a lot to learn from this. It's not just a big, spectacular, wow, look at the size of these things. Well, yeah, yes, absolutely. But there's more to it than that. And like I say, I discovered the fluid-filled highway. I wrote a paper on it back in 2015. It was called Fascia-Facilitated Fossilization. And this fluid-filled highway that coats everything in the fascia was what kept everything underneath from being invaded. All right? And it was just called a fluid-filled highway. I called it a fluid-filled network. Same thing. Giant system covers the whole body. And again, all my words from 2015. And then about 2018, they agreed, yes, this is a fluid-filled highway. It does the whole body. And now they think it's the biggest organ in the whole human body. Because it is. It covers every single cell. Every single cell touches fascia and these fluid-filled highways. Because every cell has to be serviced, and the fluid-filled highway is a service route. See, here's where it comes in with the ribosomes. Everything leads to something else. Because how are they going to get down into these? There's cells inside of all this. If these are supposed to be fluid-filled, fluid-filled barriers that keep things from not getting in, how does it get down in there to get service? Because you got fluid throughout your whole body. The servicers are in the lymph fluids. The lymph fluids are so tiny that they can go anywhere in your body. They can go through your blood-brain barrier. They can go through all of this stuff, basically. In my mind, that's what's going on. Ribosomes in that fluid-filled highway, and they just float anywhere they want. And they're so small that they just invade cells. And one single cell, of which you have literally, I think, at least they say 37 trillion or something like that in a normal human. Every single cell of those 37 trillion cells can have up to 10 million ribosomes in the single cell. Ribosomes are the packages of chemistry that do everything in life, and they're so tiny when they're in their ribosome state. They're in a ball like this, but when they do their job, they go boop, and they go huge chemicals like this. But otherwise, they can float around almost undetected. They're just everywhere. They're just everywhere in your body. And every single cell has tons of them. And like I said, they can have up to 10 million in one single cell. 10 million. And then multiply that times 37 trillion. That's a good sized number. Lots and lots. Okay, my friends, I'm going to close it up today for this, but I'm going to be doing this video about this lung. Now, this is a lung, and it's the guy's chest. And I did a video on this the other day, a few days ago. And then next day, this pops up. This is where the rover, Curiosity rover, drove over one of these lung lobes up on Mars. This is the mud that's around the lung lobe. These are the tracks of the rover. And it drove over that and crushed these lobes down. And they found these sulfur cubes inside, and they went ballistic. Say, well, why would this happen? Well, sulfur is the daughter isotope of a decaying phosphorus. All right, you look it up. Daughter isotope means once it decays, it turns into either a smaller particle or even a bigger one. And in this case, phosphorus, the phospholipids, which is all the collagens are made out of that rubbery stuff, they turned into sulfur down inside. And it was due to some of the chemistry in that area. It just bumped it up. It's called atomic bump, my terminology, by the way. And that's what created that. And this is exactly identical to this. And I did the video on it. I got it all done already. So the next video I'm gonna have will show this. I'll make another explanation about this, and then it'll go into that video showing. I had all microscope shots. I actually did catalase tests on here, and there's still blood in this. And then there is also bone in this. See, this is the guy's back. There's bones in here. And I'm going to grind some of those bones open a little bit, and which I haven't done yet. But this is his lung on the side here, and there's the top of his chest. And after the flood, everything boiled away and was left with just lobes of the lung, just like that, and then his muddy flesh, which is just nothing more than the muddy flesh there. Mars no different than Earth, no difference whatsoever. Okay, the next video is going to address the Mars Morse code, the Mars blueberries, the Mars crab, all these things. They're all biology. And this, my friends, is the rover footprint. It weighs about 2,000 pounds. It ran over something like this here, the lobes of the lung. I mean, there's no difference whatsoever. And this is the muddy flesh that surrounds the lobes. And they just driving down over that, and they went crunch and cracked it, and they looked down inside, and they could see this elemental sulfur. Well, they thought, how could this possibly be? What would make elemental sulfur, turn into globs like this? They have no idea. Well, I know exactly why. Now look at the exactly identical to this. Now, why though would it fill up with sulfur? Well, let's think about that. What is this made of? It's made out of collagen, rubbery stuff. What's the rubbery stuff made of? Phospholipids primarily. They're, membrane, because every single alveoli has a membrane around it, and every single, even blood cell has membranes around it. So we got tons of phosphorus. Well, where is phosphorus? There it is right there. Well, where's sulfur? Sulfur is right there. Well, how could phosphorus jump up and turn into sulfur? Is that possible? Well, maybe. Okay, can phosphorus jump up to sulfur, the next atomic size up? Yes, it can. And here's how it happens. You need enzymes. Enzymes do something called nucleosynthesis. This is called the nucleus of an atom, let's say. All right? And what happens is these enzymes invade the nucleus and go brrrr, and they just blow it into a bazillion pieces, and then it comes back together however that bacteria or that enzyme reassembles it and turns it into a product, a protein or an enzyme to go kill something. And here's what happens with phosphorus, which is your and my membranes. All of our rubbery stuff is made out of phosphorus. Now, it can go down and become silicon or aluminum primarily. These are the daughter isotopes. The daughter isotope means after the decay, you got your basic, element. Then it decays, right? And it can go into a daughter isotope, and it can become silicon and aluminum, which is feldspar. Yes, 100%. All of my stuff is coated with feldspar. That's feldspar coating this bone. That's transitioned into a mud fossil bone, and that's feldspar. And the reason is because there's a membrane. The membrane was made out of phospholipids, the same thing as my friend here, Caesar. And see, there's his feathers, and if somebody could tell me the pattern of this feather, I would like to know what bird has a big, gigantic feather like that on the back of their head, and then it radiates out from underneath it. You see? He's got a regular bill, or I don't know what they call it, a beak. We'll start here, and he died flat in the flood too. They all died flat, like this. All right, because there was a giant flood. Now, and it also was hot water, and the hot water boiled the phospholipids down into aluminum silicates primarily. However, in some cases they went up, and what would they do? From phosphorus, from its stable state, it can transition up. From a stable state, it can transition down into aluminum silicates primarily, but in its stable state, it goes up. This is all sulfur. Every one of these different isotopes can turn into sulfur. That's why they have so much sulfur in that lung sample. And all it is stable means there's a certain number of particles. You see the weight 15 and 16, 31? That's what stable is. 30 is not stable. It wants to become up to stable. So 30 is down here. All right, it wants one more to become stable. So it has a half-life. It says, I'll stay here for a while, but I really want to get to stable. Down here, they don't have much of a half-life at all. They got a whole bunch missing. All right, so when they decay into all these other things. Anyway, above stability, they immediately go right into sulfur. They're every one of them, 100%. 100%. That's why they found all those phospholipids. All the sulfur collected inside the alveoli. And the other video I did, I showed all of this, except I didn't know about the sulfur until this video came out. And I had already done the whole entire video. It's just amazing that this shows up hours later, literally hours. This is identical. Identical. They're driving across here, just like they're driving across here, and a wheel hits here, it goes crunch, and they say, uh-oh, and they look and they see this. That's it. That, my friends, is destiny. Manifest destiny. Something is turning this stuff on to be revealed, because this is Mars. And don't tell me it's not Mars. It is Mars. I followed this thing since this was curiosity. This was way back when they first engaged up there. They found the Mars crab, the Mars blueberries, the Mars Morse code, all biology. And I alerted to NASA. I alerted everybody about it. And now it's just so overwhelming. It's got to be addressed. To walk around in circles and just pretend it's not real, that's not science. That's not even intelligence. That's not knowledge. You think it's helpful just to ignore everything and ignorance is bliss? Well, that's what I have found. In 15 years, that's what I've discovered. That seems to be true. So anyway, I love you all, my friends. Next video, we're going to go deep into chemistry, biology, planetology, planobiology, ology. All right, so stay tuned, mes amis.